Hello, I'm Alexander Dick with the University of Manitoba's HCI Lab, and today I'll be teaching you how to use Unity with the zSpace. The zSpace is a 3D stereoscopic screen with head tracking and has a stylus for input. This tutorial will show you how to add stereoscope, head tracking, and stylus input into the game. The game we'll be using for this tutorial is the Unity survival shooter Nightmares example project. Go do that first if you haven't already, or use the completed example project in the completed folder of the downloadable assets. First, ensure your zSpace has the latest firmware and SDK. Second, download the zSpace ZS Core Unity package. Also note the documentation. I recommend you have the latest version of Unity installed. I'll be using Unity 4.6.1. Finally, in order to run Unity with Stereoscope, Unity must be opened with the Force OpenGL and Enable Stereoscopic 3D tags. Close any open project, then create a plain text file with this line in it. Save the file as a batch file using the extension .bat. If you saved it as a plain text file, you can simply alter the file name and change the extension. Drag this file into your Unity folder with unity.exe. You may get asked for permission. You can create a shortcut of the batch file and put it on your desktop for easy access. Now open Unity with the .bat shortcut and open the survival shooter Nightmares project. With the survival shooter project open and running Unity with the Force OpenGL and Enable Stereoscopic 3D tags, open the ZS Core Unity package and add it to the project. Locate the ZS Core in Assets, zSpace, Core, Resources, and drag and drop it onto your main camera game object. Reset its transform position and rotation to 0. Try running the game maximized and putting on your glasses. It probably doesn't look quite right. If your stereoscope isn't working at all, check Unity for errors. If there are any, you will want to check the previous steps again to ensure you followed them properly. You can also check your graphics card's stereoscopic settings to make sure they are enabled. Navigate to Window, zSpace, Core Diagnostic. You'll get a window full of options you can tweak. Use the Viewer Scale slider. By dragging the Viewer Scale slider back and forth with the zSpace glasses on, it will look like everything shifts between 3D and two separate images. Try to find the sweet spot where everything looks like 3D with your glasses on. I found that a value of 40 looks good for this project. Remember the setting you chose, close the window, and stop running the game. Click on the ZS Core game object and adjust the settings to your chosen values in the inspector. If you run the game again, it should look like how you adjusted it. Now that we have stereoscope working, it's time to shift input from the keyboard to the stylus. Right-click on the main camera and create a new empty game object as a child called Stylus Controller. Click Add Component and add a line renderer to it. For the line renderer, we need a material, and materials need textures. I used a plain white 64 by 64 JPEG. You can just drag and drop it from your computer onto the Unity project's Assets Textures folder. Now navigate to the Assets Materials folder, right-click, and create a new material. Call it Stylus Material, or something similar. Change the tint color to something you like. This will be the color of the beam the stylus shoots onto the screen. I recommend a lower alpha, maybe half transparent, and a dimmer color so you don't get ghosting with the stereoscope. Select a texture for the material, choosing the plain texture you created. Return to the Stylus Controller game object and open the line renderer in the inspector. Add the stylus material as element 0 under Materials. Under Parameters, change the start and end width. I used 0.1 for start width and 0.05 for the end width, so the beam narrows as it points onto the screen. You can use different start and end colors if you want the beam to be a gradient. I just use the same values as I did for the stylus material. Now go to Add Component and add a new script. Name it Stylus Script or something similar, and open it up. Here I'm using a script I've already made so I can quickly walk you through it. Make sure you are using both Unity Engine and System.collections. For this script, all of the variables are private. Don't worry about the underscores in the names, that's just how I tell private and public variables apart. First we have the ZS core, that handles the zSpace events. Second is a tracker target type, which we set to primary, which is the stylus. Third is the line renderer component. Then a vector 3 projection point, which will be the point the stylus is pointing to on the screen. Finally, we have the camera ray length, which will determine how far to shoot the stylus beam into our level. In the start function, first we get the ZS core component. Then we use it to add a new event to it called onCoreUpdate. This is a function we'll write which the ZS core will call every time it updates. Then we get the line renderer component. Next we have a function called getPointerLocation that returns the projection point of the stylus beam in the level. Next is the private onCoreUpdated function that we told the ZS core to call every time it updates. It calls the last three private functions update stylus pose, update projection point, and draw stylus beam. Update stylus pose gets information from the zSpace trackers to tell us where the stylus is in 3D space. We use this to change the stylus controller game object's position and rotation in the game relative to the camera since it's a child of the camera. Update projection point updates where the stylus is pointing to in the level. We shoot a ray from the stylus's position into the level, bounded by the camera ray length. If it hits something in the level, we get the point in that location and store it to our projection point variable. If it doesn't hit anything, we shoot a ray from the stylus and find the point at the end of the ray, which is as long as the camera ray length. Finally, there is the draw stylus beam function, which uses the line renderer to draw a line from where the stylus is to the point it's pointing at in the level. We set the initial point to where the stylus is and the second point to where the projection point is. Run the game and you should see a nice line that points from the stylus down into your game. Even if you move your head around, the beam should remain tracked to the stylus tip. Now we have the stylus beam in the level, but it doesn't do anything yet. Let's update the player movement script to use the stylus. Go to the player game object and open the player movement script. First, we'll need a public reference to the stylus script we just wrote. Add in a public stylus script variable. Save the script and go back to the Unity inspector. With player selected, click and drag the stylus controller game object into the stylus script field of the player movement script. It should automatically fill in the stylus script for you. Now, go back to the player movement script. We add the two private ZS core variables, the ZS core itself and the tracker target, once again set to the stylus. In the await function, add in getting the ZS core component. Now go to the move function. To move the player to where the stylus is pointing, we need to get the point in the level it is pointing at and move the character towards it by speed times delta time. Add in a new vector 3 called destination and initialize it to 0. Then we check if either the second or third buttons have been pressed on the tracker target, which we set to the stylus at the start of the script. If either of them is pressed, we get a destination to move the player towards by using the vector3.moveTowards function. It takes in the current position, the desired location, which is the point in the level the stylus is pointing to, and how fast it is moving to that location. Here I have it set so that if the third stylus button is pressed, the player moves backwards, and if the second stylus button is pressed, the player moves forwards. This is done by using positive or negative speed. We take the new destination and set the Y value to 0, since we don't want the player moving off of the ground. We check if the player moved, which with this implementation they always will since the stylus beam can't enter the player to point to the player's origin point. If you had the beam point through the player, then they could stop if you pointed right in the player's origin. Finally, move the player's rigid body to the new destination. After checking for stylus input, I've kept the keyboard input so the keyboard can still be used. Now if you run the game and press the two secondary stylus buttons, the player will either move towards or away from where the stylus is pointing. Now let's get the player to turn to face where the stylus is pointing. Go to the turning function. First, we need two vector 3s. The first which gets where the stylus is pointing, and the second that subtracts the player's position from the pointer's location. Then, get the new rotation using the player to stylus point. Reset the X and Z values to 0, since the character should only turn on the Y-axis. Then, update the player's rigid body with the new rotation. Run the game, and the player should now look towards where you point the stylus. Shooting is easy now that the player looks towards the stylus location. Open the player shooting script and add private zScore and tracker target type variables. Once again, for the primary target type, the stylus. Get the zScore component in the awake function. Go to the update function. In the first if statement, put parentheses around input.getButtonFire1. Inside the new parentheses, add two vertical pipes. The pipes mean logical OR, just like two ampersands mean logical AND. After the pipes, check with the zScore if the first button on the stylus is pressed. That's it. Now the player will fire if either the normal fire buttons are pressed or if the main button on the stylus is pressed. Haptic feedback is also easy to implement. Open the player health script and add a public float called vibrate time. This will be the duration in seconds that the stylus will vibrate each time the player is hurt. I have a default value of 0.4 seconds. Then add the private zScore and target type variables just like before. Again, like before, in the awake function, get the zScore component. In update, go to where the color to flash to the screen when the player is hurt is selected. First, tell the zScore to enable vibration on the tracker target, the stylus. Then, tell the zScore to vibrate the target. The function takes the target type, which is the stylus, a duration to vibrate for, which is our vibrate time variable, another float for duration between vibrates, and an int for how many times to vibrate. Since we only want to vibrate once, set the off period to 0.0 and the number of times to vibrate to 1. That's it. Now whenever an enemy hurts the player, the stylus will vibrate. Now we want to build and run the game. Go to File, Build Settings. The platform target is PC and the architecture is x86. Click on the Player Settings button and make sure stereoscopic rendering is enabled in the inspector. Back in the Build Settings window, click Build. After it's finished, go to where you stored the game on your computer. In order to properly run it on the zSpace, we need to launch the game with the same tags for OpenGL and Stereoscope that we used to launch Unity. Create a plain text file in the same folder as your game's executable file. Copy and paste the same text we used for the unity.bat file. Change the unity.exe to your game's name. Save it as a .bat. You can create a shortcut of the .bat file to put somewhere else if you like. Opening the batch file will launch your game for the zSpace. Now your game is stereoscopic with head tracking, has a visible stylus beam, is fully controllable with the stylus, and gives haptic feedback when the player is hurt.
I can see that.